Can I get a text confirmation if we are audio is okay, video is okay? A text confirmation, please. Yeah, please confirm if you all can hear me. No. Yes, audible and screen also is visible. I get this message from, okay, yeah, perfect. So people are able to hear me. Perfect. I think that's it. All right. So once again, good evening. Uh, Welcome to 360 DG TMG, our ongoing initiative to keep giving back to our participants with reference to concepts that oftentimes are not completely covered for want of time, or maybe it is not that important at that point of time during their course. And of course, small modules that people can attend as standalone modules that people can attend and make sense of it. So that's the objective of these webinars, which are duration of 1 hour, less than 1 hour predominantly. All right, so let's begin. This is our course that we are offering, and of course, a little bit of information with reference to the domain analytics program that is moving in leaps and bounds. Especially our life sciences healthcare is having a lot of traction. And of course, the next one is financial analytics and analytics for internal auditors. These are being lapped up like anything. We have already done a lot of batches for these three, and very soon for others also. Others also, a few are there, but yeah, those are things that are happening. So this is something out there in the open. And once again, people who have already attended a few of the sessions, you may be aware, but for the others, we are having accreditations with a whole bunch of internationally renowned organizations, City and Guilds, which is a certification body which is recognized by the Queen. That is there. We have UTM school, UTM Space, that is School for Professional and Continuing Education, the division of UTM, University Technology Malaysia, which is one among the top 100 universities in the world. Our curriculum is also accredited by TUV-SUD. Those are a few. Over and above that, we have also Panasonic, we have IBM, and in the pipeline for at least two more international universities, one being from UK, is what we are working towards. And we are growing in leaps and bounds. And the brand 360 DGTMG is something that will be really a force to reckon with. And just to entice you into doing these certificate programs, these are the beautiful sample, the certificates that you would obtain from the various institutions if you decide to do a full-fledged course with us. So these are some sample certificates. All right. So maximum likelihood estimation, that is the topic of discussion today. And oftentimes the word likelihood and the word probability are interchangeably used. So we'll try to understand the difference between the two, and I'll probably do a simple math to explain it to you as well. All right. So what we're going to do understand is what is probability and models parameters, and of course likelihood and maximum likelihood. These are the things that we are going to be talking of as part of this brief module that we are going to be discussing. So probability, I assume all of you have a fair understanding uh, about what probability is, and uh, it is a measure of successes upon the total. Now that is of course with reference to a discrete kind of an outcome. If it is continuous, then you are looking at what is called as the area under the curve. The assumption here is that you have done some basic. So therefore, if you are interested in the probability, so when you were to measure this entire area, you get the probability associated between a particular interval. Let us say this value is x1 and this value is x2. So x1 to x2, the probability is this area, which is given by that. Whereas likelihood is for one specific value. Now, we've also discussed, some of you who are participants of 360 DGTMG, we might have discussed that probability of a single value is not possible. Yes, probability of a single value is not possible. So what are we going to do? Are we going to, what if we actually want to study something about a single value, what do we do? So that is when we have the likelihood measure. All right. So the classic example of the concept of probability is with reference to the coin toss. All right. Landing on the head is 0.5, landing on the tails is 0.5. So probability of each side is zero point 0.5 or 50%. This is essentially what we have been drilled in our head with reference to probability. All right, and let us look at some of the parameters and distributions. All right. So we are going to have the probability from 0 to 1. All right, that is the maximum and the minimum, that is possibilities. And for an event to occur, the probabilities can range from 0 to 1, and it is practically impossible for an event never to occur. So that is why we put it 0 on the left hand side, and almost certain for a particular thing to occur is put as the probability 1. All right. So this is the parameters that we are going to be talking of with reference to the measure of probability. All right. So the parameter what we are talking of is the probability P. All right. And with reference to that particular parameter, we are now going to study about the study about the likelihood. Okay. Now, likelihood refers to the event, past events with known outcomes. Likelihood is with reference to something for which the probability is known, which automatically implies that we have already had some experience with this. So the second statement here is a little confusing, but also pretty beautifully put. The difference is that if likelihood refers to the past events with known outcomes, probability refers to the outcomes of the future events. If I were to flip the coin, what can I expect is a probability. What is the likelihood that I will get a heads when I flip the coin becomes the likelihood. That essentially is the most simple explanation that you can think of with reference to the difference between probability and likelihood. And the expressions, the method of representing them is probability of x, an event x given the parameter p is known, and similarly likelihood of x given the parameter p is known. And the objective of maximum likelihood estimation is to find those values that makes the observed data most likely. Now let me explain about that in a slide now. So before that, let us also understand a little more. I'm reiterating the same thing. knowing the parameters, outcoming the prediction, observing the data, estimating the parameters. All right, that is what is likelihood all about. I will, before I go into the math here, I would like to explain about it with, excuse me, with a simple example that I just picked off the internet. All right, so obviously I have not checked into the copyrights and all that, but I just checked it off the internet and it was a really interesting example. So we all are aware of the die, the six-faced die. All right. Now you have two dice, die A and die B. This die here is the fair die, and this die here is a loaded die. A loaded die means inside the die there is a slight weight on one side, which makes that particular side to be on the bottom. Therefore, it is always 6 on the top. So there's some inside the die here, there is a weight. All right, there's a loaded die. Now, in the appearance of it, it looks exactly the same. Both the dice look exactly the same. All right. Now, we all know the probabilities. Let us talk with the reference to the fair die. We all know the probability. So, probability of getting 1 versus 2 versus 3 versus 4, 5, 6 is equal to 1 by 6. I think this part I was not required for me to spell it out in so much detail, but all of you are aware of it. What I'm going to tell you about the loaded die, obviously the parameter probability has to be known. In the loaded die, we know that the probability of getting 6 is 1 by 2, and the probability that is 5 times more than the others, and the probability of others are equal. So you can see this 1 by 10 into 5 plus 1 by 2 is equal to 1. So we have different probabilities. We have a higher probability with reference to, that is, the probability of 6 is 5 times more than the probability of 1, 2, 3, 4, or 5. So 1 by 10, 5 times more is 1 by 2. I think that's pretty much clear. Once again, let me erase this and I'll just mention it in the corner there, or maybe I'll just erase the entire thing. All right. So I have the fair and the loaded probability of any number is equal to 1 by 6. Probability of 6 is equal to 1 by 2. Probability of rest is equal to 1 by 10. Now, I told you beforehand that I'm not aware which of these is loaded, which of these is not loaded. I pick up one of them and roll it 3 times. When I roll it 3 times, I get 6, 5, 6. Now it is possible for the outcome 6, 5, 6 to be obtained from either of the dice. I can obtain 6, 5, 6 by rolling the fair die itself. I can obtain 6, 5, 6 by rolling the loaded die. What is the likelihood that I have used the fair die versus what is the likelihood that I have used the loaded die? That is what we are trying to find out. Now, assumption being that it is a fair die. So what is the probability of 6? 1 by 6. Now, when we already are aware that when we deal with the and, it is multiplication or it is addition. So what we are looking at, 6 and 5 and 6. All right, so if you have the and, you multiply. If you have the or, you add. So 1 by 6, 1 by 6, which is equal to 1 by 216. If it was the loaded die, what is the probability of getting 6? 1 by 2. What is the probability of getting 5? 1 by 10. What is the probability of getting 6? 1 by 2. 1 by 40. Now, this value is definitely higher than this value. Therefore, the likelihood that I had rolled the loaded die is higher compared to me having rolled the fair die. This is the fundamental. This is, again, I'm just making it even easier to explain to you what likelihood means. Now, let us enter the math behind it. We will make it even more simpler. We are going to be looking at the coin toss example here. All right. So we are tossing a coin 100 times, and we are not sure about the probability. We are assuming that the probability is 0.5 for heads and for tails. Now, before we proceed any further, we need to establish certain things. P is the probability of success, and 1 minus P is the probability of failure, which obviously means it is equal to 1. The summation of P and 1 minus P is equal to 1, the total probability, because we are only taking a binomial experiment here. All right. And then next we are going to be excuse me, the total number of trials. All right, the total number of trials is n, and the successful trials is x. So the number of failure trials is n minus x. These are just some nomenclature that I want to put up right away. All right, I'll be revisiting them, don't worry about it. So getting head here is the success. Now, what is the likelihood that the probability, we have got 56 now. If you look at this particular scenario, we have got 56 times. In the 100 times that we flipped the coin, we got the heads, the successful event 56 times, and the failure event 44 times. Ideally, we should have got it exactly same, 50-50, but we got it slightly different. So given this scenario, what is the likelihood of the probability of success is what we are trying to find out. Now, we will not get into the details of the formula. Excuse me. So given that the likelihood is 0.5 and the data, so the formula is n factorial x factorial n minus x factorial. We all know x plus n minus x is n factorial, this much, into probability of success to the power x, probability of failure to the power n minus x. So this is the formula. I'll do the math behind it, and then I'll explain you what these numbers mean. All right. So when I took the probability of success and failure as the same 0.5 and zero point 0.5, when I did the math, I got a value 0.039. 0.039 is the likelihood. So the likelihood that the probability of success is 0.5 is 0.039. What if the probability of success were to be put at 0.52 instead of 0.50? The initial part of the formula remains the same. Probability of success p to the power x, 1 minus p to the power n minus x, and we get the value 0.051. Now you see here, this value has increased, which means there is a higher likelihood that the probability of getting ahead is 0.52 than the likelihood of getting ahead as 0.5. These are some numbers mentioned here. All right. And let us go into the math and let me explain it to you. I have the Excel sheet with me. All right, let me just increase the size for the benefit of everybody. Oops, give me a moment. All right. So the number of successes is 56. That is already established from this particular case study. So therefore, number of failures is 44 and the total is 100. And if I were to put the probability as 0.4, probability of success as 0.4, the likelihood formula is so much. Now let me just show you the formula here. It is, or I'll just write it down first, then probably you'll be able to understand. So this is x, this is n minus x, this is n, this is p, and this is 1 minus p. So these are the things that we are looking at, and the formula was n factorial divided by x factorial divided by n minus x factorial. As I already mentioned, we are not going to the derivation of this formula at this point of time. All right, multiplied with probability of success to the power number of times success has happened, so p to the power x, into 1 minus p probability of failure into number of times the failure has happened. Is it clear? All right. Now moving on, when I substitute the values here, so we are looking at 100 factorial, we're looking at 56 factorial, 44 factorial, multiplied with, the probability here is 0.4, so 0.4 to the power 56. 1 minus 0.4 is 0.6 to the power 44. So this is essentially what we are doing, and with this we are getting. So if you look at this formula, factorial of d8, which is 100, divided by factorial of d6, which is 56, again factorial of d7, which is 44, that is one factor. Then g6, which is your probability to the power d6, which is the success, multiplied with 1 minus g6. I think I don't have to do it, everything is essentially the same, and you get the values. So let me erase all this. Now I'm going to progressively increase, this is 0.40, and I'm going to progressively increase the probability value to find out which one of these values gives me, I think I'll go up to 0.6, starting from 0.4 to 0.6. Which of these values give me the maximum likelihood? So if you observe from 0.004, here we have 0.3, 0.5, 0.6, 0.7, 0.78, 0.8, and it starts to fall again. So this particular value here, at 0.56, we have the highest likelihood. So given the data, given that when we flipped the coin 100 times and we got 156 times success being head, and 44 times failure, the likelihood, the maximum likelihood that the probability of getting heads is 0.56. Now, this was bound to be 0.56 because in any case it is 56. There was no doubt in that. But I have tried to give it a mathematical twist to it to prove it to you, not just directly, but mathematically also. This is what it means. Now, if you were to plot this, anyway, the curve has decided to bend over, so I'm not going in for the other things. Let me just so if you notice this, and trust me when I say it will not increase, it will not go down and come again, so it is 0.56. So this essentially is the entire gamut of what maximum likelihood is, and that is the principle behind the maximum likelihood estimation. Given certain values, given certain probabilities. Now, I will quickly, in theory, explain how this works with reference to the logistic regression, because that is where the application of this is. So in your logistic regression, again, we are looking at success and failure, 1 and 0. So we already have a measure of probability. All right. From that measure of probability, we are also having the various estimates of likelihoods, the likelihood estimates from various values, and it internally calculates for which value it is the highest. Now, in this case, it says 0.56. So it takes the 0.56 value for the purpose of computing, or for the purpose of computing, or for the purpose of allocating the probabilities. So that effectively is the principle behind the maximum likelihood estimation. All right, friends. So this is what was explained here, and this is, like I said, a very short and a crisp topic explaining to you what is maximum likelihood and how do you estimate the maximum likelihood for various values of the probability. And that's about it. We'll be having more such sessions. Please do check out our social media platforms and our various handles, and then please get in touch with us for further queries. And please do write to us, give us comments, and we definitely would like to get take session. We would like to take suggestions from participants with reference to what topics they would want to be improved upon, what topics they want to be explained again. Especially, I see that quite a few of you are our former participants, so most of you would have a lot of things that you would say, okay, this aspect can be explained. We are looking for all suggestions. Please do give it, and then if you have any queries, I'll be more than happy to answer them. If not, we can close up today. Thank you. Log regression? No, we have not discussed about log likelihood. If that is what you're talking of, we are only discussing about likelihood. We are not discussing about the log likelihood. That is a different topic altogether. All right, we will discuss about why log likelihood, etc. Well, that's a good point. We will discuss. We will probably take up why log likelihood. What is the purpose of log likelihood in another session altogether. All right. So if there are no further questions, we'll close the session. Thank you so much, and good night.